Good day, everybody. Today we're gonna look at the physics, electric circuits. Today we're gonna discuss the electric circuits, the worst topic for other people. So we're gonna discuss the electric circuits, but I want to discuss this with you guys, the Ohm's law first, the basic part of electric circuits. Usually they took electric circuits from the basic Ohm's law. So we're gonna discuss the Ohm's law today so that you get the basic part of electric circuit. Then after that, we're gonna look at on the next video, we're gonna discuss the internal resistance, the series, the circuits in series, and the circuits in parallel. So once you master the basic part, the part that we discussed today, the Ohm's law, it will be better for you going forward. You're gonna succeed in this topic. I highly guarantee you guys. So let's get into it. So the electric circuits, Ohm's law. The Ohm's law is the theory. I want you guys to get this one. Ohm's law is the theory. So the theory, which simply says that I won't write everything, but I will write it in variables. So the Ohm's law simply says that the potential difference across a conductor. But let's get this first. The potential difference is the voltage on the conductor. So the potential difference is the voltage on the conductor. So which symbol is represented by the letter V. So let's get this one. So this represents the potential difference. So if this represents the potential difference, when we discuss the theory for Ohm's law, it simply says that the potential difference, so it means that the V, the letter V, the variable V, the one that represents potential difference, is directly proportional to the current in the conductor. So what represents the current in seconds? So the current is represented by the letter I in the seconds. They represent the current with the letter R. So the Ohm's law. So let's write that Ohm's law. So Ohm's law simply says that the potential difference across a conductor, you see. So the conductor is something that carries electricity from one point to another. So the potential difference across a conductor can be a wire, a conductor can be a metal. So the conductor is something that carries electricity from one point to another. So Ohm's law simply says that the potential difference across a conductor is directly proportional. So mind you, we know that the symbol for proportionality and inversely, they mean that when they say it's directly proportional, so we're gonna use the symbol as if it's alpha. It's more likely like alpha, but it's not. But it's something like slightly infinity, but you cut it on the other side. It's not infinity exactly, but it's something like infinity. So the potential difference, remember I said the potential difference is represented by the letter V. Then the potential difference across a conductor is directly proportional to the current in the conductor specifically. So provided that the temperature is kept constant, the temperature, this means that it's a temperature. Let's write that the temperature temperature this means that it's the temperature. So the temperature, if it's constant, with then we 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 are talking about the we are specifically talking about the Ohm's law, the theory Ohm's law. So Ohm's law simply focuses on the constant temperature. So the temperature, if it's not constant, they change the temperature in each and every minute, maybe hour. The temperature changes from 20 maybe to 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 25. Then the temperature is not constant. So we are not talking about Ohm's law there on that second. So if the temperature is constant, the Ohm's law simply says that the potential difference across a conductor is directly proportional to the current in the conductor, specifically if the temperature is kept constant. Then now let's 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 look at the equation for Ohm's law. Ohm's law says that I is equals to V over R. So if you look at this if you look at this equation, you can see that yes, definitely I is directly proportional to V. Then if I is directly proportional to V, then it means that I, if we increase I, also V will increase. You get that point? So if we increase I, also V will increase in such a way that they are directly proportional to each other. So, but what if we increase I? What happens to the resistance? So if we increase the I, yes, we increase I, what happens to the resistance? The resistance will drop. If we increase I, the resistance will decrease. R will decrease. Why is that? If you remember well, I said that the Ohm's law says that the potential difference across a conductor is directly proportional to the current in the conductor at a constant temperature. So they are directly proportional, but I is inversely proportional. It's inversely proportional to a resistance. So meaning that if we increase I, then this one will definitely decrease. Then if we increase R, then this one will definitely decrease. That is the reason I increases and R decreases. So this is the equation that you'll see more often. So now from the equation that we that Ohm's law discovered, then let's get the variables. Let's get the meaning for the variables. So we discussed the meanings for the variable like v and I when we were discussing the law, the Ohm's law. Now let's 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 find out what these variables mean. Then I, firstly, let's start with I. I means that means I means that it's a current that flows current that flows across a conductor, then is measured in amperes. Now get that point. Get this point. When we are dealing with the problems in electric circuits, you will meet the A more often. So just get it. Just get this in mind that A is the measure, is the amperes, is the measure of the current. The current measures the rate at which what am I saying now? The amperes measures the rate at which the current flows in the circuit. So now let's look at V. V is the potential difference. I said that on the on the on the opening of this video. This one is the potential difference. Potential difference. Potential difference. Sorry for that. It's the potential difference. So the potential difference is just the voltage. Voltage. They will say potential difference, or maybe they will say voltage, or maybe potential difference. So this one V is the potential difference. It's measured in volts. You see, you'll meet this variable more often, but get this in mind that it means it's a voltage across a conductor. So the R is just the resistance across a conductor. So it's the resistance across the conductor. So this one is just the resistance, and they use letter R, but it's measured in ohms. This one is measured in ohms. So these are the measurements for the I, V, and R. So you'll meet this one more often in this topic. So I think that's it for today, and we'll meet in the next video, guys. But until the next video, please take care.